Cylinder taper. Cylinder walls taper. Too much taper, you're not going to get a good ring seal. The cylinder's too wide at the top. 6/1000 between the bottom and the top. There's too much there. We have to take the appropriate actions to fix it. Can we overbore it? We have to see what pistons are available for it. Sometimes you can measure, you can overbore it 10,000 over. We can put a 10,000 over piston in it and be done with it. You may have to go 30,000 over to get there. Out of roundness, same thing. Too much out of round, it's not going to form a good seal. Again, action there was same thing. It's going to be an overbore. So if one of these is out of spec, we're going to have to bore it, new set of pistons, press them on, press them off, get it back out there. Bearing half, or bearing the split bearing. Okay, the bearing sticks up over the block surface. That is the crush. Okay, and remember the crush is there to actually force the bearing into its saddle, to push it harder into the block, to keep it from rotating. Okay. So it'll actually extend a little bit higher than the block and a little bit longer than the cap. So when the two come together, they crush and they push backwards into the cap and into the block. This helps with heat transfer. Again, remember, we're generating heat, but we have to control the heat. So you need the heat to move away. Don't want it to maintain in the crank or in the rod or with either one. We want to transfer it out of the rod into the crank and then from the crank into the block to the cooling system to get rid of it. Bearing spread, the bearing's wider than the hole, so when you actually push it in, it pinches in, and that helps it hold tight in that space. So that is spread. And those two are definitely on the test, so you gotta remember that. Spread and crush. Right. Okay, the ring gaps on the pistons. Okay, that's so we can get them. It's actually split so we can get it on and get it off the piston. And we didn't have a gap in it, one piece would not fit. It would actually be a part of the piston. So each time, this gives us a wear factor. Different styles of rings, but the rings are cast iron. And the face that touches the cylinder wall is either chrome or it's a moly face, which most of them are moly. Moly has a better wear pattern and it wears longer than chrome. Chrome is a little bit too shiny. Doesn't seal well. The gaps of the rings. Remember, we do not align the gaps. All the gaps have to be staggered. Every piston has at least 5 gaps there. We stagger all the gaps. If the gaps are lined up, you get a compression flow bar. It makes no power. It makes little power. And you have to check the specs. Everybody's got different specs. Just make sure that they're not lined up. Don't worry about these angles and 30 degrees from here, there, A, B, C, and D. No. When you put them in, check them all. Keep them all as far away from each other as possible. Okay, the piston pin or wrist pin. Okay, thick metal steel, thick wall steel pin, hollow. The pin is not always centered in the piston. Okay, it can be higher or lower, and depends on the compression height of the piston and the length of the connecting rod. And then two, the pin can be semi-floating or full floating. Okay, remember, semi-floating, the pin is pressed into the rod or it is pressed into the piston. Full floating, it floats, it's not pressed into either. They move in and out. They're all separate pieces. Okay, piston's coming out of the engine. We want to make sure we mark it to the hole that it's coming out of. The rod and the cap have to be marked and go together. They stay together. If it's has a stud on it, we use bolt protectors. Put rubber boots over the bolts to push it out. You take them apart, you push it out of the engine. Before we take them out, we have to check to see if the engine has a ridge in it. If there's a ridge in the engine, the ridge has to be removed first. I know we haven't done a lot with that because the engines don't have a ridge, but you need a ridge reamer to remove the ridge out of the engine, and you have to do that before you take the pistons out. And something I saw some of you doing, and the others do. The crank's at the bottom dead center. So the rod is, when it's turned over, the rod is all the way up to you. Take it out, it gives you room, and you're actually pushing the rod away from the crank so you limit it as far as damage that way. Okay, the two top rings are your compression rings. Okay. And then the oil ring is a 3-piece ring. It has 2 scrapers, has a top scraper and a bottom scraper, and it has an expander in the middle. That's to collect the oil, to help lubricate the piston pin. That scrapes the oil off, it goes through the back, through the holes in the back, and then it gets on the piston pin and drips off. Okay, crankshaft itself. And most of this stuff these are directly from off the test, so these are answers more so than anything. Crankshaft is measured for out of round. Where you see OOR, that's what that OOR is. That's for out of round. The mains are measured for size and out of round and taper. Also the rod journals, same thing. I have to look at taper. Too much taper puts the piston at an angle, creates friction, and you have the piston going up and down on an angle instead of straight up and down. Okay? End plate. Horizontal movement of the crankshaft in the engine. We have to minimize that, or it creates the same issue. We have the pistons and rods going up on an angle, too much end plate. What controls it is the thrust bearing. Usually the center bearing in the engine is the thrust bearing, and that's the one that has the sides on it. And that's where we measure end play at. We measure end play at the thrust bearing. And you can measure it 2 ways. You can use a feeler gauge, or you can use a dial indicator. Okay, connecting rod journey.